SMO Senior Section Round 2 2019 Singapore Mathematical Olympiad. I also released the junior section of this year. I will release other sections for other years. If you had any question about any problems, feel free to send message to my WhatsApp number in the description and in the comments. Also, if you want to have next videos, please subscribe and turn on the bell to have next videos. So let's see the problems of this exam. Problem number 1. In a parallelogram ABCD, the bisector of A intersects BC. So let's draw the shape. In a parallelogram ABCD, the bisector of angle A intersects BC at M. Okay, so it is, we can call, for example, this one alpha alpha, and O be the circumcenter of, okay, it says it intersects DC at M and extension of DC at N. Let O be the circumcenter of triangle MCN. Prove that OBC, I call this one beta, and call equals ODC theta. So the problem says y beta is equal to theta. Now, here we say, okay, it's alpha alpha. This is alpha, so it is also alpha because they are parallel. AD parallel to BC. It is alpha also because it is alpha. We say these two lines are parallel to each other. So we can say it is also alpha. So we've used these two are parallel and these two are parallel. Okay, so it is, we understand that CMN is an isosceles triangle. So if I connect, let me draw with pink a line. It is perpendicular bisector. Here also it is perpendicular bisector. If I want to show exactly this part. So because it is O, if you draw perpendicular to these two sides, they are equal. So, and also because it is isosceles triangle, so you can say it is X. This length is also X. This length is X. Also this length is X. I want to prove theta equals beta. So if I call this one, for example, TK, if I prove that OBK is congruent to OTD, then beta equals theta. How I can prove that? I can say in this triangle, because it is isosceles triangle, if I consider OK equals OT, if you want to prove it in exact way, so you can say, okay, this angle equals what? You should memorize angles when you draw O, it will be 90 minus alpha. There are, as I said before, there are around 50 important ideas in geometry. For example, one of them, knowing the angles when you have perpendicular bisector. If you want to know them, as I said before, feel free to send message to my WhatsApp number in the description and comments. Now, the reason is what? Let me explain this one for you. If you draw a triangle, ABC, and it is O, so you can say, okay, it is A, B, C, it is A, so this arc is 2A because it is inscribed angle, it is O central angle 2A. It is isosceles triangle, so it 100 minus 2A, 180 minus 2A over 2. Each of them will be 90 minus A. Exactly here. You see it is alpha, it is 90 minus alpha. Also, it is alpha, so you can say it is 90 minus alpha. And it is isosceles triangle, it is angle bisector also, you can say. So it is angle bisector, so you can say this length is equal to this length. So OK equals OT. Let's find one more thing. Here I say what? I say CD, let's call CD Y. So AB is also Y. So because it is isosceles triangle ABM also it is Y. So if we calculate, let me write rest of that with blue. BK is what? Is Y plus X. Also, dt is what? Y plus X. So one length here. OK is what? OK, we proved OK equals OT because CO is angle bisector. OK equals OT, so two sides, and also K equals 90 equals angle T. So we can say by two sides and angle between, we proved that triangle OKB is congruent to triangle OTD. So here theta sees this side, beta sees this side, so beta equals theta, so we proved the things that we wanted. SMO 2019 round 2 senior section problem number 2. Let n and m be positive integers such that n is greater than or equal to n plus 1 given n distinct points and m distinct line segments each joining a pair of points. Prove that there exist distinct points a0, a1, 2, am so that for each I from 0 to m-1 there is a line segment joining ai to ai plus 1. If we want to consider this problem in graph, it means that we have n vertices and mn edges. N vertices. You should know some basic things for this problem about graphs, like vertices. For example, this graph has 3 vertex, it is edge. So n vertices and line segments. How many line segments do we have? It says nm. So we have nm edges and distinct line segments. So each joining a pair of points prove that there exist points a0, am means what? It's like this. A0 is connected to a1. The problem says ai to ai plus a2 to am. So it means what? A path with length m. We consider length the number of edges. From a0 to am, we have m plus 1 vertices on this path and m edges. So a path with length m. Now, n vertices, we have mn edges. So if we consider, then let's consider this equality means what? It means what? N is greater than or equal to n plus 1. So it means it is equivalent that n minus 1 over 2n. We have how many edges? mn edges. mn edges is what it says. Mn is at most, we can say n minus 1 times n over 2, which is n choose 2. So we see that it is logical because the number of edges is at most n choose 2. Between each pair, we have an edge. So here, let's consider, for example, for a small example to see the problem means what? For example, if n is 2, then 2n plus 1 is at most 1. And okay, m and n's the problem says are integers, positive integers. So for n1, m cannot be positive integer. So for this one also m cannot be positive integer. So we should start from n3. 3 to m plus 1. M should be 1. And we have 3 vertices. Mn will be what? 3. 3 vertices, 3 edges. We want to find a path with length m. M is what? M is 1. So with length m, you can select, for example, this as a0, this as a1. So we have this thing. Now, let's consider what we can say. Suppose that we consider the maximum path. Okay, this idea is so much useful in graphs. Maximum path and one other idea are the most important ideas in graphs. And if you want to know the ideas of graphs or other lessons, as I said before, feel free to send message to my WhatsApp number in the description and comments. So here you say, okay, suppose the maximum path, for example, the length is d minus 1. So if we consider that the minimum, if 1 is connected to other, for example, vertices, then it is contradiction because we have length that is greater than maximum path. We have path that is greater than maximum path. So 1 is not connected, so 1 can only be connected to this. So let me call this one instead of d because we want to use d. For example, the length is k minus 1, k. So degree 1 is at most 2 to k, it can be connected only to 2 to k, so k minus 1. Now we said, okay, d1 is at most k minus 1. Now, if d1 is, or let me tell you, if k is at least the number of vertices, at least m plus 1, then the problem will be solved because we have a path with length m, the thing that we wanted. Otherwise, k is at most m, and d1 is at most, by this, if we call this one star, d1 is at most m minus 1. So here we have vertex 1, that the degree is at most m minus 1. So here we consider this part, we say, okay, the degree is at most m minus 1. We remove vertex 1 from this graph. Now, we want to see, can we use induction? Do we have any important thing in G1 so that we can conclude? So here we have n minus 1 vertices. And the number of edges here is at least. We had mn, and we subtract at most m minus 1, minus m minus 1. And here you can say, okay, if you factor from m, it will be m n minus 1 and plus 1 here. So the number of edges is at most m times n minus 1. And vertices, we have one condition so that we should check. So here m is, the problem says m should be at least what? N should be at least 2m plus 1. So if here we have n minus 1, if n minus 1 is at least 2m plus 1, then the problem will be, we know n is at least 2m plus 1, because in the whole graph, this condition is satisfied. Now in this part, we want to use induction. If n minus 1 is at least 2m plus 1, so we can use induction. Also, you can consider this one as the first case, base case, or when n equals 3. If n minus 1 is at least 2m plus 1, then the problem will be solved, and we have a path with length m here. Otherwise, it means what? 2m plus 1 can be what? 2m plus 1 is greater than n minus 1, so it's greater than equal n. From the assumption, from first part, this is, so we can conclude 2m plus 1 in the main graph is n. It means what? As I said, we have mn edges, the number of edge. So you can say mn equals n minus 1 over 2 times n. It will be n choose 2. So in the main graph, we have, it is a complete graph. All the vertices are connected. And, okay, m is what? M equals n minus 1 over 2. So when the graph is connected, you have a path with length n minus 1. This one to this one. So you should say n minus 1 is greater than equal n minus 1 over 2. And it is equivalent that n minus 1, 2 times n minus 1 is at least n minus 1 if it cross multiplies. This equivalent that n minus 1 is at least, if we subtract both sides by n minus 1, it will be 0. This equivalent that n is at least 1. We know n is at least 3 because m should be positive. Here we've checked. N is at least 3. And we know it is okay. So if this condition is not satisfied, so you say that we prove it, it is complete graph. If this condition is satisfied, then we can prove it by induction. So sometimes induction cause that we check, for example, induction, we say if we can't solve with induction, then otherwise we have a special case. So induction helps us like this. So if you want to learn all things about induction, also we have induction on sum of variables or other things in combinatorics. As I said before, there are around 50 important ideas. If you want to learn them, as I said before, feel free to send message to my WhatsApp number in the comments and description. Also, if you have any question about this solution, send message to me. SMO 2019 Senior Section Round 2. Problem number 3. Let A1, A2 to A2000 be distinct positive integers such that 1 is less than or equal A1 less than A2, 2 less than A2000 less than 4000, such that the LCM least common multiple of any two of them is greater than or equal 4000. Prove that A1 is at least 1334. Okay, for this problem, there is an important idea that we write each number ai as 2 to the power of, for example, alpha I times ri, which ri is odd. This form is really important and famous. If you want to know other forms, other ideas, as I said before, feel free to send message to my WhatsApp number in the description on WhatsApp, and also subscribe my YouTube channel to have new ideas. So here we say, okay, if we have how many? A1, A2, we have 2000 numbers, and Ri can be what? 1, 3, 5 to 3999. So they are around, if I consider this, the numbers in A equals 4000 over 2, which equals 2000. So because we have exactly 2000, and if two numbers, all of them are equal, for example, if Ri equals Rj, then you can say Ai divides Aj or Aj divides Ai. It depends on the power of 2. And if, for example, if Ai divides Aj, then LCM of Ai and Aj will be Aj, and we know Aj is less than 4000. When the problem says LCM of any two of them is at least 4000, so it's a contradiction. So we conclude, because it's somehow pigeonhole principle. We have 2000 numbers, and we have a special case of pigeonhole principle. We have exactly 2000 cases, and we can select one of them for example, Ai and Aj, different Ai and Aj. So exactly one of them select this. For example, one of them is 1 times 2. Let me call, because it is not, we can say it is, we are not sure that the first one, for example, 1 is for A1. So you say 1 times 2 beta 1. One number is this, one number is 3 times 2 beta 2. And it's 399 times 2 beta 2000. Yes. Okay, so here I prove the rest of that with contradiction. Suppose that, let me write with like rest of that by contradiction. Suppose that A1 is at most 1334. So you say 1334 here, 1333, less than or equal 1333. So you consider A1 is this. So we have A1, and okay, A1 is selected, but if you consider 3A1, we know it is at most 3999. So we have this number because A1 is at most this. So we can't select this number, because here we said if one of them divides the other one, then the LCM will be 3A1, and 3A1 is less than 4000. So we don't have 3A1, but 3A1 is an odd number. We said we have all odd numbers times 2 to the power of something. So we have at least 3A1 times 2. So we can say 3A1 times 2 is less than 4000. So 3A1 times 2 or times 4, because we have one of them, we know 3A1 times 2 is less than 4000, but maybe we select 3A1 times 4, because also when 3 times A1 times 4, if we select that, it is less than 4000, so it's obviously 3A1 times 2 is less than 4000. Then you say, okay, now let's consider 5A1. 5A1 again is an odd number, and it is 6A1. When 6A1 is less than 4000, also 5A1 is less than 4000. So we have 5A1. 5A1 is an odd number, so because we have A1 here, we can't select 5A1 because one of them is multiple of the other one. So we have 5A1 times 2 to the power of something. So if we consider, we can continue like this, or as I see, we can easily prove here, because you can say, let me tell you, you can say, okay, 3A1 times 2 to the power of something, 2 to the power of k, we select this, and it is 4000, we select this, it is a, for example, t, but A1 divides AT, and that's a contradiction because LCM of A1 and AT will be what? Will be AT, and it's less than 4,000, but LCM should be greater than equal 4,000, and that's a contradiction. So A1 less than or equal 1333, we've reached contradiction. So we concluded that A1 is at least 1334.